Hello everyone, hope you're doing good. Thanks for tuning in. DC TechNet is your own channel, so do like, share and subscribe. It will not take more than 2 seconds to click on that subscribe button. It motivates us to create new content. So we will continue our deep dive session on dynamic host configuration protocol, and today or this session will be the part 2 or the second part of our 3-part series on DHCP. So in part 1 we have covered what is DHCP, functions of DHCP and some of the myths about DHCP. Now in part 2 we are going to understand how DHCP works, or the DHCP lease process, and in the part 3 we are going to perform some lab activity. We are going to run some Wireshark trace logs, and it will be a completely practical session. That is part 3. So let's jump in. And today we have a question. At the end of today's session we'll be asking a question which we ask in most of the interviews. Whenever I take an interview, I ask this question. It's related to DHCP. So let's get started. So as we know that DHCP dynamically or automatically leases IP configuration to its clients. Big question, how? So there's an entire process which runs in the background called as a DHCP lease process, and this process is also known as the DORA process, D-O-R-A, DORA process. So let us understand this DORA process, or the DHCP lease process. DORA is an acronym where D stands for discover or discovery, O stands for offer, R stands for request, and A stands for acknowledgement. So this is DORA, discover, offer, request and acknowledgement. This is the DHCP lease process. So let us dive into each and every step: discover, offer, request and acknowledgement. So step number 1, DHCP discovery. So we have to ask questions now. Who discovers whom and how? So the DHCP client discovers the DHCP server. So this is the first message in the DORA process which helps find the DHCP server on the network. The DHCP client will find the DHCP server by sending a DHCP discover message. Now this particular DHCP discover message is a broadcast. It means one to everyone which are on that particular network. So this message will be heard by every device which is turned on that particular network. So as a DHCP client doesn't know the DHCP server's IP address, the message is broadcasted with the destination IP as 255.255.255.255, and the source IP will be all zeros, as the client doesn't have any IP address. So the IP address 255.255.255.255 is also known as universal broadcast IP. So the client doesn't have any IP, so it simply broadcasts the discovery message using all zeros as the IP, because even the client don't have any IP address. So here is our discovery message on the wire. So source IP 0, destination IP is 255.255.255.255. But over here, the client will broadcast its MAC address, that is A6. In this example, it is A6 colon 45 E3 F7 and so on. And it doesn't know the destination MAC address, so it will just put in all F's over there. So this is the discovery message. So let's move on. Step number 2, DHCP offer now. Now the client's task is over. Now the ball is in the court of the DHCP server. So next question is, who offers whom, what, and how? So the answer is, the DHCP server offers IP configuration to the DHCP client. The DHCP server receives the discovery message and it replies the DHCP client with the DHCP offer request. The DHCP offer request has the information about the IP address configuration and the duration of time, the lease time that the host can use. Now here the destination IP address again will be 255.255.255.255, as the DHCP client still doesn't have any IP address. So this will be again a broadcast message. So this DHCP offer message is again a broadcast on the network layer, and it will be a unicast in the data link layer, as the DHCP server knows the the MAC address of our DHCP client. So this is how our DHCP offer message looks like. If you observe over here, source MAC address means the MAC address of the DHCP server, and the destination MAC address is the MAC address of our DHCP client, and the source IP will be the IP address of our DHCP server. Step number 3, DHCP request now. Now the server has offered IP configuration to the DHCP client. Now the DHCP client will request for the IP configuration. So who requests whom, what, and how? So the DHCP client requests for IP configuration to the DHCP server. Again, DHCP client sends a request message to the DHCP server when it receives DHCP offer from the DHCP server. This message tells the DHCP server that the DHCP client has accepted the IP configuration given by the DHCP server. Now here the destination IP again will be 255.255.255.255, means it's again a broadcast, because again the DHCP client don't have any IP address yet. Now the reason for this is there might be, say, many DHCP servers in the network. So the client may receive multiple offers, and it will accept requests that reaches him first and send a broadcast message to eliminate other DHCP servers. So let's say we have 3 DHCP servers in our infrastructure, and the DHCP client service starts. It starts broadcasting. It will receive 3 offers. So it's a first come first serve basis. Whatever offer it receives, say first, it will accept it and it will reject the 2 offers. This is how the DHCP client is configured to, say, work. Now here again the source IP will be all zeros, as the DHCP server hasn't yet leased any IP address to the client. And DHCP request message is also a broadcast message. So here how our DHCP request message looks like. Source IP all zeros, destination. Here the source MAC address is the IP address of the MAC address of the DHCP client, and the destination MAC address is the MAC address of our DHCP server. Last but not the least, DHCP acknowledgement. So who acknowledges whom and how? So the DHCP server acknowledges the DHCP client. This is the last step or last message in the DORA process. So the DHCP server acknowledgement message or acknowledges to the client when it receives the request from the DHCP client. Now this message will contain the IP configuration that the server leases to the client. So the DHCP acknowledgement message will contain the core IP configuration. It might say IP address, subnet mask, say default gateway if it's configured, preferred DNS and alternate DNS. So this will say begin a broadcast message again using the same IP, that is 255.255.255.255, but it is unicast in the data link layer because everyone knows the MAC address of now the client and the server knows their MAC addresses. And this is how our acknowledgement message is. So we are going to see all these things in our lab session. So let us see DHCP messages now. Discovery message is always a broadcast. Offer message, broadcast in the network layer and unicast in the data link layer. DHCP request message, broadcast in the network layer, again unicast in the data link layer. DHCP acknowledgement message, again broadcast in the network layer, unicast in the data link layer. So let us understand the DORA process in the pictorial representation now. So we have all our clients over here. It can be a mobile phone, laptop, desktop, a printer. And we have our DHCP server over here. Now DHCP client work on port number 68 and DHCP server works on port number 67. Now as soon as the DHCP client service on any device starts, it starts broadcasting and it wants to find the DHCP server. So as soon as this message is intended, this message goes out from port number 68 and it is intended to port number 67. So port number 67 is only and only opened on DHCP server. So there might be 100 other devices on the network, active devices. So as this is a broadcast, all the other devices will drop that packet because port number 67 is blocked on them. So whenever we install DHCP server role on any Windows server, port number 67 will be automatically opened up. And DHCP server will again offer, the client will request for the offer IP configuration and DHCP server will acknowledge. And there will be one more thing, one important thing which will happen. The DHCP server also informs the DNS server to create a corresponding host A record. This is called as dynamically updating the DNS. So DHCP and DNS work hand in hand. So let's come to the question now, very important question, which say I ask in most of the interviews. What will happen if the DHCP client is not able to discover the DHCP server? Now, this is not the question why. It can be any reason. Can be say DHCP server might be down, or there might be some network issues between the client and the server. But the question is, what will happen if the DHCP client is not able to discover the DHCP server? So request you to please share your thoughts in the comment section. So our next session will be completely filled with labs. We'll be running some Wireshark network traces, and we'll be focusing on the DHCP traffic in the network trace logs. Thank you for joining today's session. Hope you have enjoyed it. If you feel this channel is helping you to learn anything new, please do not forget to share and subscribe this channel with your friends and your technical community. And see you in the next session. Thank you.